everyone. It's good to be here. Nice to see everyone. I'm Joe. I wrote the broccoli build tool. And before I dive into the presentation, I would like to give you some background about what motivated broccoli kind of. So let's say you're starting a new app. And you're writing a grunt file to build it because you want like CoffeeScript files and you have handlebars templates that you want compiled. And then you want to concatenate all the JavaScript. And for production, you also want to minify, and there's some sass, and probably more things. So you have this grunt file, and it's kind of getting lengthy, but okay. And you start working on it with a small team, couple people. And at first, it's great. You edit a file and you have grunt watch, reload the file, rebuild the output, and you reload the browser, and everything is great. But as the months pass, it gets slower and slower. And so after a couple months, you edit a file and you wait 10 seconds for it to rebuild. And then you reload in the browser. And clearly that kind of delay is unacceptable for something that is such a core part of your feedback loop as a developer. Right? This edit, reload thing is something you do hundreds of times a day. So it needs to be really, really fast. So that is what motivated Broccoli. This talk is going to have 3 parts. Part 1 is going to be a demo where I kind of show how to use Broccoli from a user's perspective. Part 2 is about how to make your own plugin. And part 3 is about how it fits into the larger ecosystem of JavaScript tooling. So let's get on with the demo. So here I have a demo app. Let's take a look. Can you read this in the back? Awesome. So we have some public files, an index.html, and a cat picture. I'm going to use that later. We have a styles folder with an app.sass file. We have a vendor directory with jQuery in it. And we have a lib directory with JavaScript. And this app doesn't have any JavaScript yet, but I put in like 200 boilerplate code files just to simulate like what building a real app is like, because it takes much longer, of course, to build like 200 CoffeeScript files like you might have in a real world app. So I'm going to start the Broccoli server, and it's building. This is the initial build. Still building. Done. Okay. So that's 6.5 seconds for the initial build. And now we can load it. There we go. So Broccoli serves it out. And now let's try what happens when we modify one file. So I'm just going to pick randomly one of these 200 files. I'm going to open it up in the editor. And let's add some real JavaScript code. So I'm going to enable live reload in the browser. Okay, and the initial build, you remember, took 6.5 seconds. So hopefully this will be faster than 6.5 seconds when I save. So I'm going to save on 3. 1, 2, 3. Okay, so it's almost instantaneous. And this is what we want for the core build pipeline, right? We edit and it pops up instantly. So let's take a look at how to write the build definition for this thing. I'm just going to derive this from scratch line by line because it's really not that hard. So we have some require calls on top where we load the plugins. And this is the broc file, by the way. This is like a grunt file, but for Broccoli, like a build definition file. So we're going to start by exporting just the public directory. So if we now start up Broccoli, if we start Broccoli serve it's going to serve all the files in the public directory. And now I'm going to add a Sass file. So we're going to declare an app CSS variable and call the Sass compiler on the styles directory. And the input is going to be app.scss, and the output is going to be assets/app.css. And so this app CSS variable represents a tree of files. And this tree is very simple. It's just going to contain one directory, assets, and that directory is going to contain one file, app.css. That's the output from Sass. And now I'm going to add this to the output. So call merge trees. And we're going to merge the public directory and app CSS. So we're just kind of copying these two trees on top of each other. And now we're going to add app.js and call the concat plugin on the lib directory. And let's get all the JavaScript files and write it to app.js. So this app.js variable again represents a tree that is going to be rebuilt as our source files change. And now I'm going to add it down here. Okay. Now we want to compile CoffeeScript. We don't have JS files yet, we have coffee files. So I'm going to put a lib-compiled tree and call the CoffeeScript filter on the lib directory. And the CoffeeScript filter is going to take all the .coffee files and compile them into .js files. It's going to return a tree with the CoffeeScript files replaced with JavaScript files. And all the files that are not CoffeeScript are just going to get passed through. So we use this tree here, lib-compiled. Okay. And finally, we wanted to add the jQuery file from the vendor directory. So that's what I'm going to do now. I'm going to call this just JavaScripts. And it's going to contain the lib-compiled tree and the vendor directory. And we're going to copy these on top of each other and use them right here. And then when we concatenate, we want jQuery to come first, and then the rest. And that's all there is to it for this app. So real-world apps tend to be a little bit more complex, so you're going to have more than 10 lines of code. But what I want you to note in here is that there is no code to maintain intermediate temporary directories. So when you do this with grunt, what's going to happen is that you have to think about all these directories that are going to hold your intermediate outputs, like what's coming out of the CoffeeScript compiler, and then sort of all these steps, you need to do all this bookkeeping for it. And Broccoli manages this for you behind the scenes. So let me run this by you again in a more visual manner. So let's visualize what's going on, right? We take the lib tree, we run it through CoffeeScript, and then we take the resulting tree in the lib-compiled variable and the vendor source directory, and we merge them into one combined tree, JavaScripts. We run the concatenator plugin, which gives us a new tree containing just one app.js file. Similarly, we take the styles source directory, run the Sass compiler, and get an app CSS tree. And then we merge the app.js, app CSS, and public trees into one final output tree. So notably, what you can see here is that the primitive that Broccoli thinks about is not a file, but it's a tree. And this is actually kind of important for some of the more complex compiler cases where thinking about processing single files is not enough, where we really want to take one or multiple trees and generate an output tree. So should you use Broccoli? It is 0.x beta software right now. So I'm confident about the architecture. I think that's the tree-based architecture is going to hold up. I'm not as confident about some of the API that we expose. So I think some of that is still going to change over the next few months. And hopefully by the end of the year, or maybe a little earlier, Broccoli is going to hit 1.0 and be stable. So you can use Broccoli if you're prepared to have some breakage as it evolves, and maybe some essential plugin for you is still missing, and you might have to write it. So if that sounds appealing to you, I would recommend you give it a try right now for your next app. Otherwise, it should be stable in a few months. So let me now talk about the plugin API that Broccoli exposes. Something that we learned from the Grunt authors was that if your build tool has a lot of API surface, it's going to be really hard to change any of it later, because you get an entire plugin ecosystem that comes to depend on this API. So basically, you can never again change any mistakes you made. So what I tried for Broccoli was to keep the core API really, really tiny, the interaction surface between plugins and Broccoli core. And then a lot of the magic that makes the fast rebuilds happen is in big helper libraries, in base classes for your plugins that take a lot of the complexity and a lot of the functionality for that. And you're generally not going to be writing it directly against the Broccoli API, but rather against one of these helper libraries that provide base classes for you. The minimum base class that you probably want to use is Broccoli Writer, but a large class of plugins fall into a category of plugins that are covered by Broccoli Filter. And that's for plugins that map one input file into one output file. An example of this is the CoffeeScript plugin, because it maps exactly one Coffee file into exactly one JavaScript file. And the API for the Broccoli Filter plugin that as a plugin author you implement, it's really easy. It's a process string method. It takes a string, so for example the CoffeeScript source, and it returns a new string, the compiled JavaScript. So here is the implementation for the CoffeeScript plugin. So I have omitted some boilerplate at the top where we subclass the filter base class. And then we set the extensions, which is just coffee, and the target extension, JS. And the core of the plugin is the process string method. It takes a string of CoffeeScript and it calls the CoffeeScript compiler and then returns the compiled JavaScript. So that's really all there is to it. Architecturally, the fast rebuild, that happens in Broccoli Filter. So Broccoli Filter brings its own cache, and if it didn't have a cache, then every time we rebuild, we would be reprocessing all the CoffeeScript files, and as we've seen, that takes like 6-7 seconds for this sample app, and we'd like to avoid that. So Broccoli Filter checks the last modified time of each input file, and it exploits the constraint that every input file, there's exactly a one-to-one relationship between input files and output files. So it knows that if the .coffee file hasn't changed, then the resulting .js file is going to be the same, and it just pulls it from the cache. And only when a file has changed will it call process string and do the actual work of recompiling. And so finally, let me talk about where Broccoli fits in. So Broccoli itself I think of it more as a library than a tool. It has a command line interface, but I'm not so sure that the standalone command line interface for Broccoli is what people are going to be using in the end. Instead, what I think is going to happen is that Broccoli is going to plug into Grunt. And so it's actually not trying to replace Grunt. Grunt is a great task runner for things like scaffolding or deploying or kicking off the test suite. Grunt is great. And I think just the core build pipeline, that should live in a separate tool. We should not be abusing Grunt as a build tool. It's really just a task runner. But then we can take the broccoli build pipeline and plug it into Grunt. We have an existing grunt-broccoli plugin, and I think we're going to be adding more functionality to that to provide more hooks into the rebuild lifecycle. So that's how I foresee broccoli being used. I also think it would be desirable to have more integration with backends. What I see happening a lot right now is that we have these completely separate JavaScript applications and backends. And I think the Rails asset pipeline has shown that it's kind of convenient if you have this integration and you can serve your static files and your API off the same server. So maybe we will see some more integration with backend servers, with Node, Rails, etc. And finally, something that I'm very excited about is default stacks like Ember CLI. So if you've used Rails, Rails New gives you this awesome Hello World application with all these things in it just set up for you. You don't have to do anything. You can just start writing your code. And I really want to get to a point where people don't write their own build definitions from scratch, but rather we have a tool like Ember CLI, which we're working on for Ember, where you say Ember New, and like Rails New, it will just give you an entire default stack. And then you will have a default build definition for broccoli. And a lot of this complexity is hopefully hidden then. So that's my talk. I'm linking a blog post about the architecture if you want to read more about what motivated some of the design choices in broccoli. And well, thank you. I'll see you all at the discussion track.
Thank you, Joe.